Good morning, viewer. Welcome to our Glory Globe TV yours breaking news. Yeah, the brain. The brain has to do more than store what happened, and it also needs to keep track of the circumstances in which an event took place. Scientists in Bonn report that the human brain may handle this by using two distinct sets of neurons, one for content and another for context. Instead of blending both types of information within single cells, the two groups appear to coordinate their activity to build memories. The findings were published in the journal Nature. People can recognize the same person or object across very different settings, such as a casual dinner with a friend versus a formal meeting with the same friend. We already know that deep in the memory centers of the brain, specific cells called concept neurons respond to this friend regardless of the environment in which he appears, says Professor Florian Morman from the Clinic for Epileptology at the UKB, who is also a member of the Transdisciplinary Research Area, Life and Health at the University of Bonn. For a memory to be useful, though, the brain has to connect that stable content to the situation in which it occurred. For the same, in rodent, single neurons often combine both types of information. Yeah, we asked ourselves, does the human brain function fundamentally differently here? Does it map content and context separately to enable a more flexible memory? And how do these separate pieces of information connect when we need to remember specific content according to context? Says Dr. Marcel Bosch, working group leader at the Department of Epileptology, a member of TRA, Life and Health at the University of Bonn. To test these ideas, the Bonn team recorded the electrical signals of individuals' neurons in people with drug resistant epilepsy. As part of clinical diagnosis, electrodes were implanted in the hippocampus and nearby brain regions of this patient, regions that are essential for memory. During monitoring to determine whether surgery might be an option, participants also choose to complete a laptop-based task. They viewed pairs of images and compared them using different prompts. And for instance, they had to decide whether an item was bigger when the trial began within the questions bigger. This allowed us to observe how the brain processes exactly the same image in different task contexts, says Morman. After examining activity from more than 3,000 neurons, the researchers found evidence for two mostly separate neurons population. Content neurons responded to particular images, that is, biscuit, regardless of the task. Context neurons responded to the task rule in questions being asked and the questions bigger. So, regardless of which image appeared, unlike patterns commonly reported in rodents, only a small number of neurons carried both signals at the same time. In this exclusive report.